for this type of valve. It may look a little complex, but there's lots to be learned just as I work the valve back and forth if you're keeping an eye on both the symbol on the right and the cutaway on the left. Sometimes this valve appears even a little bit more complex with a choke section in the middle. That's the subject for a future video. But for now, let's strip this valve right down and let's just work with that main section on the bottom. And the main section is nothing more than a very large spool-type directional control valve. The spool in these types of valves could easily be 1 inch in diameter or larger, 25 millimeters or more. The length could easily be a foot long, 30 centimeters. And flow rates could easily be 100 gallons per minute, or 400 or 500 liters per minute, or more. So these are very large valves. The question sometimes asked is, why not just install solenoids at both ends of the main spool? And of course, the reason that is not done is that the size of the winding would be very large, and the amount of electrical current required to create the magnetic force to move such a large spool would be very inefficient. So pilot pressure is brought to bear on the right-hand pilot head or the left-hand pilot head to move the valve, but in simple terms, it is just a basic spool-type directional control valve. Right now we can see that the main spool has moved to the right, and that's giving us P to A flow to possibly extend a very large hydraulic cylinder, or possibly to turn a hydraulic motor clockwise. And when our valve spool shifts to the left, we get P to B flow. Retract our cylinder, turn our hydraulic motor in the counterclockwise direction. So in basic terms, it's a simple spool valve. This particular one is showing a closed center, which means that our A and B ports are blocked, as shown here, and also our P port cannot send any flow to any other port, nor can the T port be connected to any other port when the valve is in the neutral position. And the valve is kept in its neutral position by return springs, one on each end of the spool. And so it's very important when we expect this valve to return to its center or neutral position, it's very important that the pilot pressure that may have been present on one or the other of two pilot heads gets drained away. So that's the valve main section. It's fairly basic, it's just large. Now, keeping an eye on the pilot passages that provide that pilot pressure to move the valve spool back and forth, we're going to add the pilot section back on. But for now, it's simply a matter of understanding that pilot pressure came from somewhere and filled up this left pilot head and pushed our valve spool to the right, compressing the return spring on the right. And as you see over here on the animated symbol, that is reflected by the red coloring on the pilot head symbol. So let's return to center and let's bring that pilot section back in. So now it's simply a matter of understanding that the pump both supplied the main valve spool for flow that goes to the cylinder or the motor, but the pump is also supplying our pilot pressure to the pilot section on the top of the valve. There is options to do some other types of internal works with this valve. If we were to turn this pilot plug around, we could go through a scenario called external piloting, where we could bring in an external pilot pressure separately from the system pressure. But for now, suffice to say, this valve has been configured for internal piloting, which means that the pressure used to move the main spool back and forth will be the same as the system pressure as it operates with cylinders or hydraulic motors in the system. So once again, I'll operate the valve. Now I'm energizing the solenoid on the left side, which is pulled in the left armature, pushing our spool to the right, and pilot oil has been directed to the pilot head on the right. There isn't a continuous path for oil, so you don't see flow arrows there for any length of time. Just a quick dash of white arrows show up as a very small volume of oil is delivered to a pilot head, because you only need sufficient volume of oil to drift or move the spool into position, and that's it. After that, it's really just a holding function for the pressurized oil that is there against the opposing force of the spring on the opposite side. The use of the float center on the pilot section is the most common valve center to find on the pilot section, and it makes a lot of sense that that float center is chosen because whenever we turn off the solenoid, we want the pilot pressure that may have been present only a moment ago in one or the other pilot head on the main section to be vented to tank. And you will see that there is a passage for venting the pilot pressure to tank as it moves externally out of the valve on a special passage that is often labeled port Y. Look for port Y in any pilot-operated hydraulic valve. If it is in use, then you know you have an external drain of pilot fluid. So the float center is the right one for the job for the pilot section. It allows the springs on the main section to drive the spool back to the neutral position and expel whatever excess fluid is in the pilot head and send that back to tank through the path that you see there. That's a basic introduction to solenoid-controlled pilot-operated directional control valves. In a future video,